Hello students, myself Puneet Kathuria, your physics faculty at Aakash. So in this session of physics part, we'll be covering two main prime chapters of your +1 part. So these two chapters are your gravitation and your fluids. So you can expect 2 to 3 questions from these two chapters in your NEET exam. So these are very important and very fine chapters. So let's start with the chapters. So gravitation. So when you talk about gravitation, the Newton's law of gravitation comes to your mind. So that is well thought, but the main chapter starts from the Kepler's law, and this is again one of the finest areas we have. So Kepler's laws of planetary motion. So we have 3 laws. The very first law is law of orbits. So law of orbit says all the planets revolve around sun in elliptical orbit. So when you talk about elliptical orbits, so let's understand. So this is your ellipse and sun being at one of the focuses. So all the planets, they revolve around this sun in elliptical orbit. So this is law of orbits. So these all are elliptical orbits we have. So this is the one. Then second is law of areas. So as per law of areas, it says areal velocity. So areal velocity is rate of change of area with respect to time that remains constant. So this is law of areas. So let's develop this concept. So as we can see, this is your ellipse. So this is your semi-major axis, let it be A, and this is your semi-minor axis B. So A is your semi-major axis and B, this is your semi-minor axis. Then we have another term that defines your technicality or this ellipse. This is eccentricity. This eccentricity is E, and mathematically this eccentricity is given by a square minus b square by a square. So usually the value of this eccentricity is from 0 to 1. So this is the 1. Then sun being at focus. So this is the focus part. Now this position, when planet is, let's call this planet as your Earth. So if this Earth is closer to this position and this position is your perihelion, which is nearby position, and this is RP, that is perpendicular distance from the sun. And when you talk about this position, which is far off, so this is your aphelion, and this distance is RA. Now sun being at focus, this is eccentricity times A. So I think this is very much clear to all of you from this label diagram. Now can we understand what is RP? Yes, anyone from your part? Yes, students. Can you give me the value of RP in terms of this E or A, eccentricity and A? Can you define this RP? Yes, Nishant? So if you look at this, so this is complete A, this one. And when you subtract this one, so RP is A minus EA. So this is A times 1 minus E. And when you look at RA, that is perpendicular distance of this position, aphelion position from the sun. So this is A plus EA. So that gives you A times 1 plus E, where E is eccentricity. Good, Nishant. So any doubt from this part? If you have any doubt, you can still confirm it. So we are coming to develop this second law of areas, areal velocity. Now, if you get into the details, this areal velocity is L by 2 times m, where L is angular momentum. So this is angular momentum, and we know because there is no torque acting on this system. So there is no torque, it means what? Angular momentum remains constant. So this angular momentum remains constant because there is no external torque acting on the system. And when angular momentum remains constant, so L by 2m, where m is what? M is mass of this planet. So this part remains constant. It means delta A by delta t. That means rate of change of area with respect to time. That is called its areal velocity. That remains constant. So any doubt from this part? Any doubt? Nishant? Ravinder? Okay. Eccentricity. So Ravinder is asking for this eccentricity. Ravinder, can you see these two axes? One is your semi-major axis labeled as A. The other one is your B, that is your semi-minor axis. Got it? So eccentricity mathematically is defined as A square minus B square by A square under the root. You got it or not? Right? So this is eccentricity, and we have defined position or the perpendicular distance of planet when it is at nearby position, that is perihelion position, that is given to you as A times 1 minus E, and for the aphelion part it is A 1 plus E. Got it? So that is all about for this part. So this angular momentum remains constant. If there is no external torque, it means delta A by delta t remains constant, and that is the condition for the areal velocity. Any doubt from this part? Now let's come to the questions. What questions can be asked from this particular concept? So let's build up those questions surrounding this concept only. So now, so let's discuss these two positions. Now first is when your planet is at perihelion position or when planet is at aphelion position. So we say it sweeps out equal areas in equal intervals of time. So for that, let's suppose it sweeps out this much area, and here it is far off, so it sweeps out this much area. So aerial velocity remains constant whether you are at perihelion position or you are at ephelion position. But to maintain that aerial velocity, the position of this perihelion, so at perihelion position, omega would be faster. This is at perihelion position. And at ephelion position, this omega would be comparatively a slower one. So this is just to maintain the aerial velocity constant when particle is, or when planet is at nearby position, that is called perihelion position, your speed would be slower. And when you are at this position, perihelion position, that means when you are at far off position from the sun, the omega would be a bit faster as compared to this position. Do we understand this? Any doubt from this part? This you can use it from law of conservation of angular momentum that clearly says I omega at perihelion is I omega at ephelion. Now if you look at this, I, moment of inertia, if you can see moment of inertia at let's suppose perihelion position. So with respect to perihelion position, this is nearby, so this perpendicular distance is bit smaller. So moment of inertia would be small when you compare it with the moment of inertia of the same planet about the center at ephelion. So what is this? IA is more than what? IP, but you have to make this product, you have to maintain this product as constant. It means, so when you talk about P, that is P, so this is smaller, IA is this. So for this one, when you look at this, so omega P, perihelion, it would be rather slower, and ephelion, I omega, ephelion is slower, sorry, so that was correct. Ephelion position is this one, so I is more at ephelion, so omega would be slower, so that is this one. So that also confirms that when you are at perihelion position, your planet would be moving at perihelion position, your planet would be moving faster. So omega would be quite large as compared to when you are at ephelion position. Any doubt from this part? Any doubt? Sure? Now, if I ask you to compare their linear speeds also, can we? So your conservation of angular momentum, so MVR. So let's do it for perihelion position, and this is MVR at ephelion position. This M goes. Can you see this? So if you have to compare these two, Vp by Va means velocity of the body at perihelion to velocity of the body at ephelion. Can you write this ratio Vp by Va as Vp by Va is Ra by Rp? Can you see this ratio using this concept? So we know Ra and Rp. You got it? So RA, this is A times 1 plus E, and this is A times 1 minus E. So this common feature goes, this common feature A goes, and now we have the ratio in terms of eccentricity also. So it means this numerator is more than this, so Vp is more than this one. So this is how we understand this. So Vp means when you are at this position, the speed of the planet would be more. You got it or not? Now, if I ask you what is the kinetic energy as you move from perihelion, aphelion point or between these 2 points. So when you are nearby, omega is fast, so linear speed would also be fast at perihelion position. So Vp is what? More than Va. Do we understand? So when you say Vp is more than Va, it means kinetic energy would also be more as compared to this position. Any doubt from this part? Tyasha Adhikare, sir, please explain once again in which position the omega is faster. Now look at this. Can you see this? So when you are at perihelion position means nearby position. So when you are at nearby position, when you are at perihelion position, omega would be faster. And when you are far away or when you are at the other position, that is called aphelion position, omega would be a bit slower as compared to the aphelion position. Yes, Tyasha, any doubt? Just if you have any question from this area, please understand it thoroughly well, because these are the questions which are regularly asked from this particular section. So if you have any doubt, you please confirm your doubt, then we'll plan to move next also. Any doubt? So now let's conclude this law very well. So this is your elliptical path, sun is somewhere here. This nearby position is called perihelion position, and this far off position is called aphelion position. So perihelion position. So if I ask you this one, perihelion position, so the radius is A times one minus E, and for this position, aphelion, this is A times 1 plus E. Got it? Here, to maintain aerial velocity constant, this omega would be what? Omega would be faster, and here omega would be slower. You got it or not? And MVR at perihelion position is equal to MVARA. So you can compare these two also, Vp by Va, in terms of Ra by Rp. Ra by Rp is this one. You got it or not? Now, if I ask you omega, so do we understand? V is equal to omega R. If you look at this for the circular motion, So can you fit and can you compare omega p by omega a also? Yes, using this relation we can. Any doubt? So these are the areas, these are the questions, these are the important formats which are being asked from this particular section of your Kepler's second law. Now moving to the third law, Kepler's third law, planetary laws we are discussing. So third law is law of periods. So third law is law of periods. It says time period of this planet which is revolving around sun. So square of the time period. I'm not writing the statement of the third law, or rather I have not written statement of any of the law. So just pay attention what I am giving you verbally. The square of the time period is directly proportional to the cube of semi-major axis. Semi-major axis. Make it a point. So t square is directly proportional to r cube, and this is called law of periods. Got it? Any doubt? Any doubt? It means with this r, how time period is directly related to this r. So you can understand, if I ask you to draw the graph of this part only. Yes. So how you define the graph of this? What kind of shape you expect between these two variables, t square and r cube? Yes, please answer it, participate. Nishant, you can well answer it. Tiasha, you can also answer it, Bicha. Savita. Now, this is directly proportional. So graph would definitely be a straight line when you have t square and r cube. So this graph would be a straight line. But t is directly proportional to r 3 by 2. So when you have a graph t with respect to r, this will not be a straight line. Straight line is when you have direct proportionality. The moment this power increases, so graph will turn towards this side. So this graph will not be a straight line, rather this will be a slight curvature moving slightly upward. That is with respect to the straight line, it will be somewhere on this side. Do we understand? So this is all about your Kepler's laws of planetary motion. And this is one of the important areas of your gravitation part. That is why I have taken it very, I've tried to explain you in bit of detail also. Any doubt from this part? If you have any doubt, please come forward, clear your doubt, then we'll move forward. And then let's attempt few questions which are based on this law, or rather based on all the three laws of planetary motion, Kepler's laws. So before that, if you have any doubt? Any doubt? No doubt? So shall we move? Fine. So now whatever we have covered from the gravitation part, let's attempt few questions based on that particular concept only. So Kepler's second law is based on, is it based on law of conservation of area? No. Is it based on law of conservation of momentum? Is it based on law of conservation of angular momentum, or based on law of conservation of energy? Law of conservation of energy is a universal concept, but this these Kepler's laws are not defined on the basis of law of conservation of energy. Rather, energy is being changed. Total energy will remain constant, but as you have seen, the speed varies all along the path. So speed would be different at perihelion position when you compare it with the aphelion position. So kinetic energy, potential energy. So they are the two variables. Law of conservation of angular momentum. Yes, this is the area, and that defines the law of areas. Law of conservation of momentum. No. So this is a PYQ NEET based question, that Kepler's second law is based on law of conservation of angular momentum. Any doubt? So Tyasha, she has given me the right option. Ravinder has given me the right option. Good. So any doubt from this part? So once you are clear about the concept, then you can attempt all these questions with just one click. So that is why I have paid, or I have given you more attention for the concept building part. Now let's move to the next question. Let me change the color of this. If I take blue one, it's visible here also, it's visible on this one also, that's fine. So that would make our purpose. So this is the time period. Now the question is the time period of satellite at height r, that is from the surface, that is t. The time period in an orbit of radius 3r, where r is the again radius of Earth. So this is purely a ratio based concept and based on law of areas. So first of all, law of area says t square is directly proportional to r cube. This blue is clearly visible. Okay, fine. So we can continue with the blue, and I think blue is visible here also, on this part also. So that is rather more exciting, interesting. Now what is the small r? Small r is basically the orbit radius. So if you have, let's suppose Earth, its radius is r. Got it? Now time period of a satellite at a height, when you say at a height, and this height is also equal to r. So you are talking for this part. Now what is the orbital radius? So orbital radius becomes 2r. I think this point is clear to everyone. Any doubt from this part? So what is the cube of this? That would be 8r cube. Got it? So we have understood the meaning of small r, that is radius of the orbit. Now, the time period in an orbit of radius 3r. Now this is not stated at a height. The question itself says this is orbital radius. So this small r is given to us. So let's call this as t dash. And when you take the cube of this, so that would give you 27 r cube only. So I think we are clear on this part. When height is given to you from the surface, how you will define the orbital radius, that we have understood it. And when directly it is the orbital radius, then it is clearly understood as 3r orbital radius. So this is 27 r cube. Now take the ratio. Got it or not? So what is t dash square? So that is equal to t square 27 by 8. And when you take so this is 9 into 3. So when you take square root both the sides, so 9 into 3, so that gives you 3 root 3, and that gives you 2 root 2. So how you will define t dash? So that would be So before you pick your option, just look at the option A. Is it the correct one? No. B is the correct one? No. What is the correct option? C. So you have to again recheck, re-verify your answer whether you have got the correct answer as per the given choices, because sometimes there must be some confusion when you compare your answer and the options given. So sometimes in the final stages you may have to readjust as per the options. Means some mathematical calculations may need to be readjusted as per the given 4 options. So this is a clear option C, and D is also wrong. So this is again one of the important question, or this is one of the important topics. So we have just understood how to attempt this kind of question. Any doubt? So Ravinder, option C. Yes, Savita has also given option C, and Tiasha also has given option C. Good. So very good. Keep focusing. Any doubt from this part? Any doubt? Before we move, I must suggest you please clear your doubts before you move to the next step. All good? Shall we move? Okay. Now, this is a question. The period of revolution of a satellite around a planet in an orbit of radius 3r is t. Its period of revolution in an orbit of radius 9r will be. So this is a question. I am giving you this question for your, your self attempt. So giving you at least 1 minute, complete 1 minute to solve for this. Yes, please go ahead. I am here only. I am giving you time to solve this. We have already discussed this part. Please go ahead. Fast fire one. I don't know. Can you give me your original name, please? Fast fire 84 has given the 4th option. Okay, fine. Wait for the other students to answer the same. Fine. So now we know Aditya. Good, Aditya. Good. Now, as per your, again, the Kepler's law of periods, your t square is directly proportional to r cube. And make it a point, this r cube is basically, small r is what? Small r is your radius of the orbit. We have to be very clear. So, revolution of a satellite around a planet in an orbit of radius 3r is t. So t is already known to us for the orbital radius 3r. So cube of this 3r will give you 27 r cube. Fine. And its period of revolution in an orbit of radius 9r. Let's time period be taken as t dash, and this is again orbital radius. So this is orbit of radius 9r. So cube of 9r is what? So 9r. So this is, let it be very clear. So this is, because we have to ultimately take the ratio. So sometimes you have to be very smart when you answer this. Reason being, because sometimes when you multiply this one, and this multiplication will consume some time, and finally when you have to take the ratio, you know you have to take the ratio for all these questions. You will be again lost in your calculation. So be sensible when you attempt. So this r cube goes, and this is 3. You got it or not? So t dash square is equal to 3 into 9 t square. T dash would be, so this is 3 when you take the square root, so and this becomes root 3 and t square becomes t. So bacho, you have to be very smart when you do the calculation. So calculation is the one trap area where you have to, and I'll suggest you can keep avoiding the calculation till the last step, but you have to maintain the steps so that you can find out the error if something goes wrong in the calculation part. Got it or not? So this is t dash is 3 root 3 t, and this is the fourth option. These options are not there. So fourth option. Any doubt? So Aditya was the first one, as he clearly mentioned fast fires, so no doubt gave the right option. Fourth one, good. Ravinder also gave me the fourth option. Tyasha, fourth option, but t should be outside of the root. What is this t should be outside of the root? Tyasha, in the fourth option. Yes. Yes. Good, Tyasha. So you are, I'm like, this clearly suggests you are well focused in the class. So this t has to be outside this root. Clearly stated in the answer. So there is some typographical error in this. So just ignore this and just follow the answer given, and it seems to be the fourth option. The other three options, rather here also t should not be part of the square root. So just ignoring all these factors, just focus on the part. Any doubt? Good, Tyasha, good, keep it up. So shall we move? Now this is again option. The time of Earth is taken as t and its distance from the sun as r. What will be the distance of a certain planet from sun whose time period is 64 times that of Earth? So you have to find out the distance now. So again, going by the same format, this is t and this is r cube only. Got it? So let it be t square. Now for the t dash, this is r dash cube. We have to find out r dash in terms of r. But t dash, what is this? Whose time period is 64 times that of Earth. You got it or not? So take the ratio t by t dash is equal to r by r dash, or let's maintain square only, or if I just ignore this, let it be like this. So this is t, this is 64 times t, it goes. Can we take cube root both the sides, and this is cube of what? 4. So when you take cube root, it becomes, and when you take cube root, it becomes what? Now when you take the square, r dash power 1 by 2, or this is in root only, and when you take this square, so this is, so we got r dash in terms of r. So this is the other way, the same concept from the same law, but now this time it is being asked in a different way. So this is another question from the same Kepler's law of planetary motion, and this is the third law, that is Kepler's law of periods. So I think with all these 4-5 questions, you people have understood it well. Any doubt? And this time again Aditya has given the fastest answer as 16. Good, Aditya, keep it up. Any doubt? So let's move. Now, a planet revolving around Sun sweeps area A1 in 2 days, A2 in 4 days, and A3 in 8 days. The ratio of A1 ratio A2 ratio A3. So your law says aerial velocity, that is this, remains constant. This is what we have understood. So it travels, sweeps out it sweeps out area A1 in 2 days, A2 in what? 4 days, A3 in 8 days. So this is 1 ratio 2 ratio 4 is the correct option for the ratio of A1 ratio A2 ratio A3. So this is another question from the same concept, Kepler's law of periods. So Ravinder has given me the right option. So I think we should move on now. Shall we? Any doubt? Fine. Find another. When a planet comes closer to Sun, when you have closer to Sun, can you name me the position when it is closer to Sun? Can anyone participate? This is what? Perihelion position. So sometimes there is a challenge for the students to memorize these two words clearly. You got it or not? So it's linear speed. So I think I have given you the option. Its linear speed also increases. I gave it to you. We did discuss this part very well in detail. Yes or no? I think we did. So shall we move? Fine. Now moving to the next concept, universal law of gravitation. Very important, very fundamental, very basic law. So it says these two masses, are always attracting each other with a force which is directly proportional to product of the masses and inverse to the square of the separation between these two masses. So this is following the inverse square law. So this is the universal law of gravitation, Newton's law of gravitation. Now this is a formula and this is between these two masses. So important characteristics. So let's quickly wrap up these properties or the characteristics. Why? Because you may find some conceptual question based on these properties also. So that is why this is again one of the important areas we have. So what is this? So what we know, this is one of the fundamental forces we have. This is the weakest force of nature. This is attractive force. This is central force. It always acts along the line joining the center of these two masses, these two particles. You got it or not? Then this is a conservative force. Very important, conservative force. Gravitational force is a conservative force. It is independent of the path followed, or work done is independent of path of the follow. Work done. So it's not conservative force. Most of the students remember it as a wrong definition. Conservative force in which work done is independent of the path. It depends only on the initial and the final position. Negative work done by this force is directly proportional to increase, or that gives you increase in negative work done, increase in potential energy. The positive work done gives you decrease in potential energy. Work done round the trip is 0, and this force is also negative of potential energy gradient. So these are the important characteristics for conservative force. And gravitational force being a conservative force, so when it is a conservative force, so it satisfies all the characteristics or properties or features of conservative force also. Got it? So this is the one. It follows inverse square law also. So when you say inverse square law, so this force decreases as the separation increases. Got it or not? Any doubt from this part? Right? So there are other properties also, like superposition principle. So we'll be discussing that superposition principle. What is that superposition principle is? So for the time being, I think we have understood this part. And you know, gravitational force in terms of vector form, or you say it's vector form of the gravitational force. The same force can also be written like this. Now, force experienced by mass 1 due to 2 and force experienced by 2 due to 1, magnitude wise they are equal. And this is a very standard question. So this ratio is 1. Any doubt? So Aditya has asked me, fast fire 84, that is Aditya has asked me, please explain central force means. Central, C-E-N-T-R-A-L, A-L is basically adjective ending, so that pertains to the force which acts along the line joining the center of the two masses, that is central, pertaining to center line, that is line joining the center of these two, so that is central. So yes, I think Aditya that is clear to you now. Any doubt from this part? Universal law of gravitation. So what we are writing is magnitude of this one. So this is universal law of gravitation. Let's build up some basic numericals based on this. If masses are doubled, keeping R, that is separation, between these two masses same, then find new force between the masses? This is the simple question. So initially your masses, they are assumed to be separated by separation R. Masses are taken as m1, m2. Then the new force F dash G. G is universal gravitational constant, and value of this G, if I precisely write G somewhere here, that is 6.67 into 10 raised to power minus 11. We'll comment on the unit wise. So when you define the unit wise, so this is Newton meter square plus kg square. You got it? And dimensionally, you can build up Newton as MLT minus 2. Meter means L square and kg means m square. So I think very well you can have the dimensions or the dimensional formula for the G also. Any doubt from this part? Now coming back to this one, if masses are doubled, keeping separation as same, and this is the second one, can you see this F dash? The new force would be what? The new force would be 4 times the initial force. This is the simplest of all. And if I ask you percentage increase in force, so that would define F dash minus F by F into 100, and this is 300%. So that would give me 300% as the increase in the force. Any doubt from this part? Any doubt? Take your time, just go through it, understand it, thoroughly revise it, and if you have any question coming to your mind, please. So Aditya has given me again the right option. Tyasha, good, 300%, 4F, the new force. Good. So if you have no doubts, no questions from this part, let's move. Now this is something interesting. Look at the question. What question says? If the distance between Earth and Sun is increased by 2%, then find percentage change in gravitational force acting between them. Yes. Now this is just a 2%. Now important, gravitational force is given by G, mass of one planet, that is Sun, mass of other Earth, and this is R square. G constant, mass of Sun, mass of Earth, all are constant. So only variable is this separation. Got it? Now this is increased. We know when you increase R, it follows inverse square law. So with the increase in R, force would definitely decrease. This is the first point. Second, how you'll approach? If you get, this is like 2%. Don't get involved in your calculation. That would make your calculation very complex, very difficult. Now, whenever you have any increase or decrease less than 5%, means 5% or maximum you can say even 6%, then error method. Which method? Error method. combination of errors. So it means percentage change in F would be, look at the power of this separation, this is 2. So that would be 2 times percentage change in R. That means this percentage change in R is 2%, so that makes 4%. Now, if only a numerical value is there, then it would be easy for you to pick the answer as 4%. But if they write it as 4% increase, 4% decrease, then look at this relation. Just observe the relation, how force is varying. Is it varying directly? Is it varying inversely? And we have just discussed with the increase in R, F decreases. So there would be a change, and that change would be a decreasing change of 4% when you change your separation by 2%. So again, I'm really happy. Aditya, Ravinder, they all are answering well. Good, great. So keeping your momentum high, I think you people are doing great and understanding the concepts well also. Fine. So shall I give you one more numerical? Shall I? Okay. So let's attempt one practice numerical. If masses are increased by 50%, keeping separation R again as same or constant, find percentage change in gravitational force F between these two masses. Now it's your chance, giving you 1 minute complete to attempt this. Please go ahead. Tyasha ने एक she has shared her concern, and that is a valid concern for most of the students. Sir, मेरा एक problem हो रहा है. This is from the Tyasha side. मैं question solve तो कर पा रही हूँ, पर मेरा calculation becomes complex. Yes, Tyasha, this is a standard problem being faced by more than 90% of the students. इसीलिए मैंने आपको बोला है, I have suggested you one thing, keep your calculation easy. So first you try to understand the basic all these concepts well, so that you know which formula is to be used, and every question we can solve it in just 1 or 2 steps, maximum 2 steps, not more than that. But that is basically a practice that will come to you only through rigorous repetitive practice only. So I'm here to help you, guide you for all these small questions. In the shortest possible way, so that you people can solve it exactly in the minimum possible time. Jasmeet Kaur, sir, I will crack NEET 2025. I am wishing you good luck. Great, Jasmeet, no doubt. So if you have faith in yourself, nobody can stop you. Definitely you will be able to crack. And fast fire, Aditya has given me 125% increase. So let's do it. So when force is F for masses 1 and 2, so the formula is F is equal to G m1 m2 by r square. The new force when it is increased by 50%, so that would be 1.5 m1, and this is 1.5 m2 by r square. And when you look at F dash, So the F dash would be 2.25 times F. Percentage increase, this is into 100, so that would give you 125%. So Aditya Ravinder has also now got the answer as 125%. That's good. Great, Ravinder. So any doubt from this part? Shall we? Now, coming to this. Now, this is a question for your practice. If masses of two spherical bodies are quadrupled. Quadrupled. What do you mean by quadrupled? It's 4 times. And distance between their centers is doubled, that is 2 times. Then percentage increase in force of gravitation between them. So, we know this is F G m1 m2 by r square. This is the first equation. F dash g, masses are quadrupled. So these are multiplied by a factor of 4. So g 4 m1 4 m2 by center. I mean like their centers, the separation is doubled. So that means 2r whole square will make it. Take the ratio and this will give me F dash, new force as this one, and percentage change F dash minus F by F into 100, that defines again as 300% only. So this is the D option. Good. Tyasha got the answer. Aditya also got the answer. That's good. Great. You people are doing a good job. Keep it up. Keep it up. So, I think now you have understood these questions. Ultimately, your struggle would be not with the formula, not with the concept. Now, your struggle will be, first struggle would come when you understand the question. If you have understood the question well, then the second struggle would be your calculation part. But that struggle is beyond my control. You people can manage it well if you know the formula, if you are confident, and if you know the shortcuts without getting much involved in the calculation part, you can solve it very easily. Good, great. So let's move to the next. Yes. Now before you attempt this question, I would like to add on very important. I would like to build up an important concept for you. Let's suppose I give you a mass m. I'm not writing the statement again. I'm not dictating the statement. I'll be just putting up a situation. I'll just break down the situation into small steps so that you can develop the concept. Now let's suppose you split this mass into 2 pieces. So the first piece is small m, then the second piece would be capital M minus small m, and this capital M was constant. This is a fixed mass. Now they are just separated by the separation r. Now what is the force between them? Force is given by F G m1 m2 by r square. So your force becomes G small m capital M minus small m by r square. Question is, find m by m ratio such that force between them is maximum. Such that force between them is maximum. So this is the situation. So what is the situation? I am just concluding it. I have given you one mass, capital M. My question is, if I split or break this mass into two parts, I have not stated whether these two parts are same, equal, unequal. I have not stated it. You have to give me the ratio of these two masses, small m by capital M. In what ratio or in what, I'm like this proportion should I split so that they should experience the maximum force. Maximum force. Got it or not? Now, if you look at this, this capital G is constant, capital M is constant, and we have kept it at a constant separation also. So this force is a function of small m. And when this force is a function of small m, and to define the force maximum, the very first rule says differentiate this force because it's a function of small m. dF by dm has to be 0. This is the prime condition. Is this the only condition we have? No. In addition to this, we have another condition. The second order derivative, right, for the force to be maximum. You got it or not? So what is this force to be maximum? This has to be negative, or shall I say this has to be less than 0. You got it or not? Now let's check this. So when you differentiate d by df, so these participants will not be there, but if I open this bracket, this is the one, and what is the derivative of this? Small m dm by dm, this m is constant, so this will not participate in the derivative, and that gives you 1. Then minus m square will give me this one, and you have to put it at 0. So this means m by 2 is m. So we have to find out the ratio. So m by this m is 1:2. This is the option we were looking for. Got it? But please check the second order derivative. So second order derivative for this part, d square f by dm square, it gives me -2, which is a negative value, less than this. So no doubt, so it satisfies the relation. For force to be maximum, second order derivative has to be negative, and which is confirmed by your question itself. It gives me second order derivative of f with respect to small m gives me -2. So that satisfies the condition for the force to be maximum. And your question was for this ratio, and this ratio is 1:2. Any doubt from this part? So Aditya has quoted me the right answer. Ravinder has also quoted me the right answer. Good. Any doubt? Shall we move? Now coming back to the main question. A point mass capital M, 2 kg, breaks apart. So let me change the color. So it breaks apart into two particles of masses m1 and m2. The final masses are now placed at fixed separation of 2 meters. The force between the masses would be maximum. This is the same question, and I have just built up your concept. So if you have this 2 kg mass, then you split this into 2 equal parts, 1 kg each. So that will make final masses as 1 kg as per your last discussion. So C option. So Aditya, you gave me the right option, C. Good. So all these questions are from your NEET PYQ areas. So please focus on all these concepts very well. If you have any doubt, anything you would like to clear, you please confirm it. You can question. If you have any question or anything coming to your mind, you can just ask your question right now so that I can answer your question. So I think now we can move on. No doubt. Let's move on. Now we have superposition principle. We have just seen the force between two masses is a vector concept. You got it? So what this superposition principle is? So superposition principle says if a mass is surrounded by n number of masses, then the net force experienced by that mass is vector sum of all the individual forces. So I'm not giving you the definition on board, rather I'll be giving you one very fine numerical based on this. So let's build up a case where you have three masses. They are placed at the corners of an equilateral triangle. This is the concept. Let's suppose you have small mass m that is placed at the centroid. Question is, find net force experienced by small m at centroid. Now, let it be position 1, let it be position 2, let it be position 3. Got it? Now this mass is attracted towards this mass. What is this? Let's label this force. Let's label this force. Let's label this force as F1. Got it? If you look at all three forces, they are equal in magnitude because they are between the same pair of the masses, capital M and small m. F2 is also capital M, small m. F3 is also between the same pair. Got it? Now look at these two. The resultant of, let it be F4. So this is F2, F3, 2 times F2, F3 cos. Can you see this angle as 120? And this is F, this is F, so 2F square. This is 2F square cos 120 is minus 1 by 2. Under the root this goes, and when you solve it, it comes out to be F only. Now when this F4 is numerically equal to F and this is opposite to this F, this is also F, so net force experienced by small m at the centroid is 0. So this is a symmetrical, and this is superposition principle that clearly says the net force experienced by this mass at the centroid is vector sum of all the three forces acting simultaneously. This is superposition principle. There is another important property when you are talking about force between a given pair. Let's suppose this is the given pair. Then force between a given pair is independent of the presence of the other masses. This is also one of the important characteristics. When we talk about force between given pair, That means that force between given pair is independent of presence. The net force will definitely be different when it is surrounded by this. That net force experienced by this. But when you talk about this pair, so this is independent of the presence of the other one. This is important. Got it or not? Plus, because this mass is simultaneously interacting with this mass, m1, m2, m3 and so on. So this is the gravitational force. Another property or characteristics, we can observe it from this. It is unsaturated in nature. This is unsaturated in nature. Got it or not? Any doubt? I think we are clear on this part. So just by observing this superposition principle, we have added two more new concepts also. That means the first one, we have added how to calculate the force in gravitational form, one thing. Second thing, force between given pair of masses is independent of the presence of other masses. That is another feature we have added to our knowledge. Third feature, third important area we have just covered is like this force, gravitational force as a whole is unsaturated. A mass can interact or it attracts. Now when you talk about the mass interacts, so there is one more point is coming to my mind. What is the interactive particle? Interactive particle or interaction particle in case of gravitation force, that is known as graviton. So this is again one more feature we have added. So I was just discussing the features. So graviton we have just added, unsaturated nature we have added, then superposition principle we have stated, how to calculate it we have stated, and force between given pair of masses is independent of the other masses. So all these features have added to your theoretical understanding of your Newton's law of gravitation. Any doubt? Any doubt if you have? You can confirm it, you can clear it. So let's move to the next one. This is question. Two stationary particles of mass 25 kg and 49 kg are 12 meter apart. If a third particle is placed on a line joining the particles and it experiences no resultant gravitational force, then distance of this particle from 25 kg mass as shown. So this is the configuration. So let's suppose this mass is placed at a distance x. So this is r minus x, or shall I say directly 12 minus x. Got it? So this mass is being attracted by this particle and this mass is being attracted by this particle. Net force experience is 0. So that clearly says, let's label this force as F1, this force as F2. It means these two forces F1 and F2, they are definitely opposite in direction but has to be equal in magnitude. So how you calculate it? Let me pick a different bright color. So G 25 kg is the first mass, small m. So this is the one and they are separated by separation x. For the other force, it is G 49 kg, mass is still m, the other mass, and this is. Now, so once you have this much, the rest is your calculation part. So you can take, as you can see, now I think there was one student, Tiasha, look at this. Can you see this is basically what? This is value which can be squared off perfectly. So when you take the square root on both the sides, so that gives you 5 by x and that gives you 7 by 12 minus x. So these are the small minor steps which you have to look for, and that would make your life easy. So this makes when you cross multiply it, so 60 by 12, that gives me the value of x as 5 from the 25, and from the other one that makes it 7 meters. So, but your question is asking then the distance of this particle from 25 kg mass, so it means we have to answer it from in terms of x only, and this is 5 meters. Any doubt? Nilesh has given me the option as D. Good. Tyasha, she has also given me the option D. Shall we move? Now we have another concept, acceleration due to gravity. So we are adding acceleration due to gravity. So basically, when you allow your body to fall under the effect of gravitational pull, let's suppose that pull is for your planet Earth, then the acceleration acquired by the body, that is called acceleration due to gravity, and we write it as this small g, which is given to us as gm by r square. Got it or not? Now this is the first formula we have it for the acceleration due to gravity, and when you consider this Earth as a uniform sphere of uniform density, then mass of Earth can be written as its volume into density. So this is how we have another formula, and that gives me 4 by 3 pi g r, and d is the density. Got it or not? So we have another formula. This is acceleration due to gravity, and when you solve, put the values of all these variables, so you will have value of acceleration due to gravity as g, small g as 9.8 meter per second square, and that value is assumed to be constant at the surface of Earth. Do we understand? Now, I am giving you a very simple question. Find acceleration due to gravity on a planet whose mass is twice and radius is half that of Earth. So for Earth, this is g m by r square. For that planet, capital G, same, mass of Earth, that is twice, mass of planet is twice the mass of Earth, and radius is half, so that becomes, this is r by 2, so that makes it r square by 4. And again you take the ratio, so all these, so this 4 makes you 8. Got it or not? This is how. You can have the question based on this formula also, when like the same numerical can be asked in a different way, that size is double or density is same, or you can be asked in terms of ratio of, like you can be given in terms of radius and density of the planet with respect to Earth. So that is another question, and you can solve it again by doing the calculations in ratio form. Any doubt from this part? Now, if you look at this formula, then this g seems to be varying. Okay. Now, before we attempt this question, I think we have to build up few concepts. So, let me pick up this side. So, we have to find out variation of G with height or altitude. Now, if in the first situation, if h is comparable to your size or the radius of Earth, then the formula for this would be given by this relation. Got it? But under the same heading, if height is very, very small as compared to this one, then G dash would be given by this formula. Do we understand? And when you have variation with respect to depth, how G varies with respect to depth. So, let's suppose you have a Earth, its radius is no doubt r, but if you move to a depth d, so at this point acceleration due to gravity is given by 1 minus d by r. Just pay attention, depth is from the surface, so this value of d is taken from the surface. So, these are the formulas, you have to keep it in mind when you solve for all these varieties of questions. And based on this, when you move to the center of Earth, acceleration due to gravity would be 0, and this is how it grows directly as you come from the center towards the surface and finally outside the surface. This is how it varies with respect to r. So, this is for the depth and this is at the center of Earth. So, these are the formulas, you have to keep it in mind when you attempt these varieties of questions. Now, let us move to the numerical based on this. The very first question says, at what height the acceleration due to gravity will be reduced to 36% of its value on the surface. Now, first of all, tell me, do we understand it is reduced to? Okay. It means reduced to in the sense means the final G would be 36% of its value on the surface. So, this is the one. Now, is this 36% drop in acceleration due to gravity, is it a small drop, small change, or it's a very big change? You have to decide, small change or a big change. I think this is a very big change. And with the, if you have understood it, with the gain in height, acceleration due to gravity decreases. It means this height would definitely be a significantly large, and this height would be comparable to this. So, the formula used for this would be given by this formula. Do we understand? And we have to find out this h in terms of this one. So, this goes, and again look at the mathematical way of doing it. Take square root both the sides. So, 6r plus 6h, that gives me r, and we know radius of Earth is fixed as kilometers, or we can do it in meters also. Clear? Any doubt from this part? Now, if I change this word, now the gravity will be reduced by 36%. Initially we had it reduced to 36%, but this time now we are saying it is reduced by 36%. When you say it is reduced by 36%, it means G dash would be 100 minus 36, 64% of G. And the very same, because this is a very large height, so we'll go by the same formula, and that makes it so look at this. I'm like, just by replacing one word will have a different meaning of the same. So this is how you have to interpret your questions. This is how you have to understand it well, and then only you can solve it. Got it or not? Got it? Any doubt from this part? And if this percentage value is again a very small percentage, maybe in terms of 5-6% only, then you'll go by the error method. You'll find out using error method. So this is, now we have, now we know m into g is weight. If your g varies, definitely weight also varies. So the next question is about weight. A body weighs 300 Newton on the surface of the earth. How much will it weigh at a distance 1/3 of the radius of earth from center of earth? From center of earth. So first we have to understand it. This is the radius. At a distance 1/3 of the radius of earth from center. From center. 1/3. What is this? Depth. Do we understand? And we know G with respect to depth is given by, do we? And we multiplied both sides by this. So the new weight original is 120. 1 minus this depth is 2r by 3. So that makes it 1 by 3. And primarily this is 40 newtons. Oh, this is what? 300 newtons. Sorry. So I have taken a wrong value. Here it is 300 newtons. So I don't know how this figure came to my mind. So this is 300 newtons. So when you divide this 300 by this 3, so that makes it definitely 100 Newton only as your answer. So this is the first option we have. Any doubt? Any doubt from this part? I think clear. So Aditya is again giving me the right option. Tyasha is also participating well. Now, two planets have the same average mass density, but their radii are in the ratio 1:2. The ratio of their respective acceleration due to gravity on their surface is. I think this is visible. This color is also visible or not? Yes, it is visible on this white part also. So ratio of their acceleration due to gravity, we know acceleration due to gravity is gm by r square. So they have the same average mass density. Got it or not? So the other formula for g was 4 by 3 pi g r into density. Now this is constant part and density is also same. So g1 by G2 is definitely the ratio of their radii only, the ratio of their radii, that is 1:2. So this ratio is the first option we have. Any doubt from this part? Any doubt? So let's move further. Now, at what height above the Earth's surface the value of G is same as that at a depth of 100 kilometers? Now, first of all, if I give it to you like this, G at a depth is G at an altitude or at a height. For the depth part, this is G1 minus d by r, and for the altitude part, again for the small values only, this is valid for height, which is very small as compared to this radius. So when you compare, these two values are same. So when you look at it thoroughly, you will get this value d as same as that of 2 times height. At what height? So in the second, we have to find out height. The value of G is same as that depth of. So depth is 100 kilometer by 2, and that will give me the height as 50 kilometer only. So look at this. If you remember this relation, I think this question is also quite interesting and easy to answer. Any doubt from this part? Gravitational potential energy. So this statement wise amount of work done in bringing a body from infinity to a given point under the influence of the other body. Now let's build up the concept also of the potential energy. Let's suppose you have mass m, that is for the Earth, radius is r, you have a body m, maybe at this one. So what is the, force? So force, I can call it as G capital M small m by x square. You got it or not? Now let's suppose you bring this particle down, or this particle is coming down. So what is the small work done when it is moving towards the Earth? So this is F into dx. This is a positive work done, and this is for the total work done. You have to integrate it and you will get the total work done. What is the formula for this? Is gmm by x square can be written as, so that gives me minus 1 by x. Now if I define this point, maybe infinity. So if I define work done from infinity to maybe surface, so position at the surface is r. So this is basically the concept of gravitational potential energy. So you have to just put the limits, and this is from infinity to surface. So minus g m 1 by r minus 1 by infinity, and that defines as minus g m by r as the concept of gravitational potential energy. Now, so this is minus g m, where capital M is mass of Earth, small m is mass of body, r is the size. So if I say gravitational potential energy for two masses separated by distance r. So this gravitational potential energy is minus g m1 m2 by r. And if I define gravitational potential energy for system. Let it be M1, M2, M3 separated by R12, R13, R23. The gravitational potential energy of the system is. Now for the system part, what you have to do is define the pair. So this is the first pair. So this is minus G M1 M2 by R12. Second pair is G M2 M3 by R23, and the third pair is minus G M1 M3 by R13, and that defines the gravitational potential energy for the system. Got it? So based on this, you have, this is again one of the important areas. So let's calculate how much minimum energy is required to move a stationary body of mass m from an orbit of radius 2r to 3r, stationary body. This is mass of Earth. For clarity's sake, if I define this mass small m, because you don't get confused with the capital M, because capital M I am taking it as mass of Earth. So radius is, this orbital radius is 2r. So this is small m. So what is the potential energy for this pair? This is minus G m m by 2r. So this is the concept. And if I have to take it to an orbit of radius 3r, so the same mass is taken to this position where the orbital separation radius becomes 3r. So what is the final potential energy? That is minus G capital M small m by 3r. We have to find out energy required. So that energy required, minimum energy required is U final minus U initial, and that is minus G m m by 3r. Minus minus becomes plus, so this is G m m by 2r. And when you solve it, you will get the answer for this one. So this is how you have to approach when you have to define the potential energy for a given pair. Got it or not? Now let's build up one more situational numerical where you have three masses. They are at the corners of an equilateral triangle. Separation is A. And you change the configuration, keeping masses same, but separation is reduced to A by 2. What is the initial potential energy of the system? For one pair, it is minus G m1 m2 by A. And now we have three pairs. So this is the one pair, this is another pair, this is another pair. So this is the initial energy. For the final energy, it is minus G m1 m2 by A by 2, and this is again. And for the work done, or maybe for the change, the energy required is UF minus. So this is the work done in bringing this change. So just by putting the values, you can have the options or the answers. Got it? Any doubt? Gravitational potential energy associated with two particle system can be defined due to which property of gravitational force? When we started gravitational force, I did mention it to you. There are certain questions which can be asked from the properties or the characteristics part, and this is this conservative nature, is this weakest, is it saturated or none of the above, and potential energy is associated or potential energy is defined only for gravitational forces or gravitational field. There is no question of potential energy if you are talking or discussing your non-conservative forces. Non-conservative forces are dissipative forces, frictional forces. Got it or not? In those forces, there is no question of potential energy. So this is clear to everyone. Gravitational potential. So gravitational potential due to gravitational force of Earth is defined as the potential energy of a particle of unit mass at that point. Gravitational potential is what? So this is potential energy what? Potential energy was defined it like this. When you say per unit mass, so simply remove this mass and you will have minus G capital M by R as the gravitational potential. This is a scalar physical quantity. You got it or not? Unit wise, this is potential energy per unit mass, and we can define the dimensions proportionally, accordingly. Now, so if I ask you one very fine question, let it be. This is a square and we have a configuration, 4 masses. So find potential energy of the system and gravitational potential at the center of the square. Got it or not? So when you define potential energy of the system, just count how many pairs you can have. 1, 2, 3, 4. So 4 pairs G M1 M2 by A. Can you have 2 more pairs? Got it? But what about the potential? Potential is primarily because of these 4 masses. So for the first mass, so this is minus Gm, and this is also negative sign, no doubt. You got it or not? Then gravitational potential at the center is minus Gm by, what is this separation? This would be A by root 2, half of the diagonal. So when diagonal is root 2a, root 2a by 2 is a by root 2, and then we have 4 masses. So this is the gravitational potential at the center. So these are the questions from this particular section. Any doubt? Tyasha is asking, sir, please give a 3 to 4 minute break. Tyasha, you can take a break. I'll also have a glass of water. By the time you just note it down, I'll give you not 3 to 4 minutes, but I'll give you 1 to 2 minute break. And the screen is on, camera is on, everything is on. So please stay tuned. We'll continue with the other part. We have yet to cover the liquid part. So please be online. Yes, students. Now we got the break. Let's move on. Escape speed. So this deals with the word itself, escape. So this is the minimum speed with which a body is projected upward so as to overcome the gravitational pull of Earth, so as to escape from the field region of Earth. That is called escape speed. So now just pay attention. If you have to calculate it, this is like Earth, mass and size, body is placed at this position, and what is the speed with which it is projected upward? Let's call it as V escape, so that it just reaches outside the field region. So this can be easily treated, or this can be easily solved using your concept of conservation of energy. So what is the total energy? Initially has to be total energy at the final position. So this is kinetic energy plus potential energy. Sorry, this is potential energy, and this is kinetic energy final plus potential energy final. Let it be final. So when you just place the body, so the final speed would be 0. So kinetic energy would be 0, and this potential energy, this is outside the field region, potential energy would also be 0, because we know with the increase in this separation, potential energy would be decreasing within the moment it crosses the field region. It is beyond the gravitational pull of Earth. This energy would be 0. Now kinetic energy with which it is projected is half mv escape square. Potential energy is minus gmm at the surface of Earth, and when you rearrange it, this becomes this one. And if you consider this mass as 4/3 pi r cube into density, the same escape speed can be written like this. And when you make use of capital Gm, we know capital Gm can be written as gr square. So this escape speed can be written as root 2gr also. Got it? So you have to memorize all the formulas before you attempt any numerical. And when you look at this escape speed is inversely proportional to r. Here it is directly proportional to r. Here it is directly proportional to root of r. So that does not mean that whenever it is being said or given that radius or the size is doubled, so one person can answer it as 1 by root 2, the other person is saying it becomes double, the other person is saying it becomes root 2. No. You have to look for the other parameter given. Why this is? Because this g is assumed to be constant. Here the density is assumed to be constant. Here this capital M, that is mass, is assumed to be constant. So before you answer for any of these variables, you have to be very particular how you have to answer it. So this is the escape speed, and important parameter, if you launch your particle at an angle theta, it makes no difference, escape speed would remain same. That would be root 2gr only. You got it or not? Independent of this angle. Second, if you just ignore the bulging effect or the shape, the escape speed would remain same. But definitely this escape speed would be different. It would depend on the height from where it is being projected. So let's understand it. How? So let's suppose instead of, for the second situation, let's make use of the same. Let's suppose you launch a body from this height. You got it or not? And then again you project it. So then will the escape speed will be same what you had it when you projected it from the surface of Earth or when you're doing it from a height? Will it be same? So going by the same, what is different? Potential energy would be different. And this is how escape speed varies with respect to height also. You got it or not? This is very important. If you look at this formula, I'm like mass of the object, this one. So escape speed is independent of the mass of the object. It depends only on the mass of the planet, that is Earth size. Here it depends only on g, and this here it depends on size and the density. So just by keeping all the formulas intact, you can answer varieties of conceptual questions and you can answer the varieties of numericals also. Let's move to the numerical. Two planets A and B have same density. The radius of A is twice that of B, the ratio of escape speeds. So escape speed is 2g mass in terms of density by r, the whole under the root. You got it or not? Now look at this. So we have to find out the escape speed from the surface of planets A. So let it be escape speed A, escape speed B. If they have the same density, so this goes, all these factors are already constant, and this is r square. And when you take the root, so it becomes r only. So this is Ra by Rb, and that is, yes, the radius of A is twice as of B. So this is 2:1, option A. That is the correct choice for this one. Savita, sir, do you conduct live class on tomorrow? I think you people have a shared schedule, so please verify that. Please check your shared one. That will have that will give you the clear information. Aditya, sir, I am scoring 660 plus in test. How can I reach to 700 plus? Just by doing your error analysis, you can find out the areas where you are lacking and just working out on those areas very minutely, just jotting down all the formulas, practicing the questions related to your weak areas, and I'm like, definitely with some written practice and all, you can make it. So this is the one. Now the next question is, escape speed from Earth does not depend on the direction in which an object is projected. So this is assertion. No, this is statement wise, and we have just stated, yes, this is a true statement. Escape speed depends on the mass of the object. No, this is wrong statement. We have just discussed it is independent of mass, so statement A is correct while statement B is incorrect. The escape velocity from Earth is 11 km. The escape velocity from a planet having twice the radius and same mean density. So escape speed is, what is this? 2 gm this is the one. So same mean density, again this is the one, this is constant, this is constant, this is, all these are constant. So this is primarily depending on r only, twice the radius, so that will make radius of Earth and this planet having twice the radius, so 2re, so that becomes 2 times ve, and that means 22 km per second is the correct choice. Escape velocity of an object from Earth's surface independent of mass of object. Yes. Depends on mass of Earth. Yes. Depends on radius of Earth. Yes. All are correct. So this is how, this is the power of understanding. Once you have understood it well, you can answer it like this. So moving to next, particle is projected with a speed less than escape speed, its mechanical energy is. Now, we know if a particle is projected with a speed less than, it will never overcome the gravitational field, it will remain within the field, and particle within the field will always have mechanical energy as negative at all the points, be it here, wherever it is. So it will have negative energy. Energy required to move a satellite of mass m from a circular orbit of radius 2r to 4r. Now, move a satellite. So this is, I think I should discuss the satellite first. So what do you mean by a satellite? So any planetary body that revolves around Earth in a well-defined orbit, that is called satellite. So let's suppose this is your Earth of radius r, height h. So here the satellite is orbiting. So the gravitational force between the satellite and the Earth provides necessary centripetal force to your satellite. And that gives me the concept of orbital speed. So your orbital speed comes out to be gm by if this is very near to Earth, then orbital speed would be you got it or not? So this is the formula for the orbital speed. Now if I have to ask, or I have to find out the time period for this satellite, so time period would be 2 pi so that gives me, so orbital speed is gm by r plus h under the root, this is t, and when you square both sides, this is constant, so t square is directly proportional to r cube. It clearly follows your law of orbits. Now if I calculate the energy of satellite, so potential energy plus kinetic energy, because this is orbiting, so definitely it has some kinetic energy also. Potential energy of the satellite is minus gm m by r plus h. So this is again the orbital radius. Kinetic energy always remain positive, half m v orbital square. So v orbital square is what? This is v orbital square, and your total energy becomes now if you look at this, the magnitude of total energy is equal to kinetic energy. So this is very fine relation we have, and total, this is the total energy. So total energy is definitely what is the relation? So this is the total energy and this is the potential energy. So total energy and potential energy is what? So this part is potential energy. So just pay attention for all these formulas because these are very, very important. You may be asked questions from any of the formulas given. Now, weight experienced by astronaut in a spaceship while orbiting the Earth is 0. Yes, this is a correct statement. If you look at this, this is your Earth, this is your spacecraft, so this is mg, and centrifugal force, centripetal force. So this is being balanced by this when you look at from that satellite point of view. So this is how? This is 0. Kinetic energy of a satellite is positive. Yes, we have just stated kinetic energy will always be positive, and rather if you look at the graph, so it is the kinetic energy that is on this side, and potential energy and total energy they are on the lower side because they both are negative. So in the same question, statement 1 is correct, statement 2 is correct. So both statement 1 and 2 are correct. So this is the option. The orbital velocity of a satellite at a height 2r from the surface of the earth will be, okay, this is the expression, you just read it. What is the height? 2r, so that becomes 3r. So, but this is in terms of small g and r, this can be written as, this r goes with this, and this is gr by 3 under the root. So this is the fourth option we have. So shall we move? Satellite is moving very close to a planet of density rho. The time period of the satellite, I think you people can make it out. Time period of the satellite is 2 pi r by v orbital, and this is 2 pi r. V orbital is g m by r under the root. So this is 2 pi r, and this is r power 3 by 2 gm. Got it or not? And mass we can put in terms of volume as 4 by 3 pi r cube into density g. So density is on this side, g is on this side. This is T. So this is 2, this is 3 by 2, and this is rho g, and this is what? Pi r cube. So can you pick the option? This is how you take the ratio. So what you're left with is, this 3 is on numerator side, and I think we had 2 on this side. R density g is there, d is there, and here we have r power 3 by 2, and here we have r cube. So you take this ratio, and this is how we'll have the answer. So this is in the under the root part. You got it or not? So this 3 pi g, where is pi? Pi is there. I think we are skipping something. The time period of satellite. So mass we have this. R is the, this is in under the root part. Bacha, this is how we have. So this is, let me just write down this part again, because this is in under the root part. So let me take square. So let me just write down from this part again, because we missed out the square part. So let's square this. So this is 4 pi square, this becomes r cube, and this becomes gm. And for this part, this is 4 by 3 pi, and this is what? Mass 4 by 3 pi r cube into density. You got it or not? So this 4 pi goes, this 3 pi r cube goes, and this is g times density. Is there anything else? And this is t square, and when you take the root, 3 pi root, this is the answer, because this is t square. Got it or not? So t is 3 pi density into g under the root. This is the answer. Shall we move? When height of a satellite is increased, definitely its potential energy increases, kinetic energy decreases. Now we are coming to the next part, that is fluids. Anything that can flow, that is called fluids. So primarily this chapter or this is involving your liquid part, and so first we have the very first concept we have is for the pressure. So what is the pressure exerted by the liquid column of height h? So that is h rho g, where h is height of the liquid column, rho is the density, and g is definitely acceleration due to gravity. If you change in this concept, then definitely pressure would be different, and this is how we define pressure exerted. But if you have average pressure on the walls of the container, this is half of h rho g. So there is a difference. What is the pressure exerted by the liquid column? That is h rho g. And what is the pressure exerted on the walls of the container? That average pressure is half h rho g. You got it or not? Anything from this part? Then we have important concept based on this. So this is basically Pascal law. So Pascal law says whenever you have a fluid, then whatever particles or point of observation at the same level in the same fluid, they will all have the same pressure. So just to understand this, I'll consider 4 points. So this is full of fluid. So the points or the positions which are at same level, horizontal level in a given fluid, they all will have the same pressure, and pressure is h rho g. So based on this, pressure at A is equal to pressure at C. This is Pascal law. And pressure at B is definitely more than pressure at A, which is equal to pressure at C, which is more than pressure at D. So this is a very, very famous numerical. This is a very, very famous. You are given 4 options, but you have to select the best option or the correct option rather. So this would be the correct choice for this kind of question. If various combination of pressures are given to you, then you have to pick the option from this one, and this is the correct option. Pressure at B, which is at the deeper inside this liquid, they have, so this point B has a greater height of the liquid, so that is why pressure at B is more as compared to pressure at A and C. A and C, they are at same level as per Pascal law, so they are in the same liquid at the same level, so they will have the same pressure. And pressure at D is the smallest or the lowest among all the 4 points. So this is Pascal law. Now, I would like to discuss. I'm explaining a very fine concept, that is concept of U-tube. This is not a U-tube of your digital media. This is a U-tube, basically a liquid column tube. So we have a liquid column tube. Got it? So let's suppose we have some type of liquid. You got it? Let's label this liquid as density 1. It may be mercury or it may be anything. Now what you do is you simply pour another type of liquid of density rho 2, height h in one of the columns. The moment you put extra liquid in one limb of this U-tube, it puts pressure and will bring this level of the liquid, it gets lowered by value x. You got it? The moment it gets lowered by value f, simultaneously the other free surface will get raised by same value x. Do we understand this point or not? So how this tube will look like, so this is the same liquid 1, and this may be the liquid 2 of height h. So this is how your container looks like after this liquid is settled or finally balanced in both the limbs. Now, important point to be noted. Can you see these 2 points? If you look at these 2 points, it was lowered by value x, it was increased by value x. So primarily this is 2x of the same liquid, and this is height of the liquid for the second liquid, rho 2. As per your Pascal law, so when this is settled, Pascal law clearly says, pressure at point A is equal to pressure at point B, because both the points are in the same liquid at the same level. So if you look at the pressure exerted at point A by this, so pressure exerted is h rho g, so this h is 2x and the liquid density is rho 1 and g is your acceleration due to gravity. At point B we have height of the liquid as h, density is rho 2 into g, and that defines. So if I ask you this is h rho 2 by rho 1, or this is the 2x. If I ask you the difference in their free surface, so this is the free surface of this liquid, this is the free surface of this liquid, so I'm talking about this. So first of all, you have value of x as h rho 2 by rho 1, and this is 2 is there. So this is how, if I ask you what is the value of this x by which this is, this liquid is decreased in value, or by what value the liquid in the other column is increased. So this is one part. Second part, if I ask you the difference in their relative free surfaces, so this is I'm asking about. So h1 minus 2x. If you look at this 2x, h we have taken it as common, and this is the value I am looking for. So this is one of the important areas from this liquid U-tube column part, and this seems to be very interesting area. So I think you have understood this part. Any doubt from this part you have? If you have any doubt, please confirm it. Please clarify your doubt. Please ask your doubt, because this is very important area, bachcho. So shall we move? Now, based on this, 3 vessels containing same liquid up to the same height h, then pressure at the bottom is A1 is greater than A2 greater than A3. So we know pressure exerted by liquid column is given by h rho g. This is the pressure. So height is same type of liquid, so density is also same and G is also same. So that is same in all the three cases. It does not depend on the area of the, like your surfaces or your bottoms A1, A2, A3. So this is the common paradox we have for this situation, where all the three liquids seems to be like in different containers. They have different shapes, they may have different base area, but till they have the same height, same density, that is same type of liquid, and G is same, the pressure exerted on the surfaces or the bottoms will be same. So this is important. Now this is statement based question. For a liquid in equilibrium, the pressure is same at all points in a horizontal plane. Yes, this is a true statement, and this is what we have just stated as the Pascal law only. Second, whenever external pressure is applied on any part of enclosed fluid, this is ideal fluid contained in a vessel, it is transmitted undiminished and equally in all directions. Yes, this is also true statement, and this is the second form of your Pascal law. Pascal law also says if, and this is for ideal fluid, if pressure is exerted at any point of a fluid in an enclosed container, this is we are talking about ideal fluid, non-viscous, incompressible. So if pressure is applied at any point, then this pressure is transmitted to whole of the liquid as such undiminished. So this is the second statement. So both statement 1 and 2 are correct. Any doubt? So Savita, she has given the right option, both are correct. Very fine. Tyasha, Divyaraj and Rahul and your Aditya, fast fire, you please get charged up again. So moving to next, hydraulic lift works on this principle of Pascal law. Hydraulic lift says so let's suppose this is piston fitted and this is also piston. Here you apply some force and area of cross section is A1. So what is the pressure at this? The other side is also fitted with a piston. Area of cross section is A2. So this also experiences force F2 and this will get lifted up as pressure remains same. So this is the basic working principle for your hydraulic lift. So this is Pascal law, very fine statement. Now based on this we have a numerical. The neck and bottom of a bottle filled with water are 1 centimeter and 10 centimeter in radius respectively. If a cork is pressed with a force of this in the neck of the bottle, then force exerted on the bottom. So this is purely your F1 by A1 is equal to F2 by pi R2 squared. So this force is 10 Newton. So here we apply 10 Newton pi this 1 centimeter radius. So this is 1 centimeter square only. This F2 we have to find out. Pi we cancel out. R2 is 10. 10 square means 100 centimeter square, and that defines the value of F2. So F2 is what? 10 into 100, that gives me 1000 newtons. So based on this, we have just got the answer. So this is very important. Pascal law, very important for your fluid part. Don't ignore it. This is very, very important. Archimedes principle. So Archimedes principle says whenever a body is immersed in a fluid, maybe partially or wholly, it experiences some upthrust, and because of that its apparent weight is less than the actual weight. Now this weight loss by the body when it is immersed in a fluid, this is equal to weight of the liquid displaced, and which is same as that of upthrust. Got it or not? You got it? So this is a body which is immersed in this liquid. Its weight is mg. It experiences an upthrust. Upthrust is volume of the body, density of the liquid into g. So apparent weight of the body is weight minus upthrust and it says weight loss by the body when it is immersed, maybe partially or fully, this is equal to weight of liquid displaced, and this is equal to upthrust. Got it? Now, I would like to build a very fine example. That example would help you to solve varieties of numerical. So let's suppose we have a container and you have water. Got it? So this is water precisely, and we know density of water is, either you write down 1000 kg per cubic meter or you write down 1 gram per cubic centimeter, one and the same thing. Then you consider a small block of ice. So this is ice. So let's say total volume of the ice is V, and let's suppose this part is small v. So volume of ice, that is above the surface of water, and volume of ice immersed, that is equal to V minus V. This is V minus V. Got it? So this is the situation. Now you have and you have upthrust. Do we understand this? Got it or not? So this will give us a very fine condition, volume immersed to total volume of the body, and this will give me density of liquid by density of this is density of body by density of liquid. This is the ratio will end up, and this is a very standardized ratio. This is very, very important ratio because this will help us to solve varieties of numericals. So if you want, I can solve this how we are getting this shortcut also, but not required. So we need to keep this formula or this shortcut in mind. So based on this, you may have a question which is again there. So solid body floating in water has 1/5 of its volume immersed in it. So volume immersed is 1/5, total volume is this. Solid body immersed in it in water. So density of water is 1. Got it? We are talking in terms of CGS system. What fraction of its volume when it is immersed in a liquid of specific gravities? So whenever we say specific gravity, it is the density of that liquid with respect to density of water. So this is 1.2. of times of density of water. Can you take the ratio? And when you take this ratio, you will get volume of V dash by V. Do V or V dash in terms of V. So this goes, this goes, this goes, this goes. So V dash by V or V by V dash. So this 1.2 and this is 1 by 5 rather. Let me write down. So this will give me what? And this is multiplied to U like this, and this will give me V dash by V, and this is 1/6 of the volume that is immersed. So look at the beauty of that shortcut. That shortcut has given us the power to solve or attempt this kind of question in just one step, with one click, with one go. And this is what you have to learn. This is what you have to understand. Any doubt from this part? Tyasha, Divyaraj, Rahul, Aditya, Savita. Now we have equation of continuity. So this equation of continuity, this is for ideal fluid flow, or what kind of flow we are talking about? Streamline flow. And equation of continuity is basically whatever input mass you allow, that mass, same output, you will get it at the other end if you allow your liquid to flow through a pipe. So it means rate of flow of liquid, that is area of cross section into speed, remains constant. So this is based on your mass conservation. Whatever mass you give it the input, the same mass you will get it at the output, that is conservation of mass. So this is based on conservation of mass, not momentum, not energy, and this is wrong. So equation of continuity says AV remains constant, or A1 V1 is equal to A2 V2. Rate of flow of liquid remains constant. Any doubt from this part? Let's move. Now calculate the velocity. This is again very important area. Calculate the velocity of flow of ideal fluid V3 in the lower branch of the tube. So first you look at the diagram. So this is area of cross section A1, this is V1, this is A2, this is V2, and this is A3, and this is V3. So this is purely the flow of liquid, and it is based on equation of continuity, which clearly says A1 V1. So this fluid is branching out in these two tubes. So A2 V2 is a plus A3 V3. So this is how the rate of flow of liquid is dividing between these two umbilic channels. So A1, what is A1? 0.8, V1 is 10. What is A2? A2 is what? 0.5. What is V2? V2 is 8 plus A3. A3 is 0.4. What is V3? We are supposed to find out V3. So that gives me 8. That gives me 4. So 4 is equal to 0.4 V3, and this gives me value of V3 as 10, keeping the unit same. meter per second. So 10 meter per second, D option is the correct option we have. Shall we? Bernoulli's principle, again, this Bernoulli's principle is to do with the total energy of the fluid. So this is purely based on conservation of energy. It says pressure energy plus kinetic energy plus potential energy of the fluid remains constant. So this is P delta V plus half m V square plus mgh, that remains constant. Now when you say potential energy per unit mass, so this per unit mass is something like this. Sorry, this is rather total energy per unit mass. So mass per unit volume becomes density. So we can write down here density also and per unit weight. So this becomes so this total energy of the fluid, that is for ideal fluid, that remains constant. So this is total energy of the fluid that comprises of pressure energy, kinetic energy, potential energy, and this is total energy of the fluid per unit mass, and this is the total energy per unit weight. This is called pressure head. This is called velocity head, that is contribution from the velocity part, and this is basically, this is potential head, gravitational head, and this is rather pressure head. So this is your Bernoulli's theorem that deals with the total energy of ideal fluid, that remains constant. So Bernoulli's principle is based on the conservation of what? Conservation of momentum, no. Conservation of mass, no. Conservation of energy, yes. Angular momentum, no. So third option, that is option number C. So shall we move? Viscosity. Now viscosity is basically property of the liquid by virtue of which it kills its own motion. This is also treated like a liquid friction, and we know liquid, it exists in layers, got it, and you have cohesive forces between these different molecules of the different layers. So whenever you try to slide this surface, the next layer will also come into motion, but with a lesser speed, the next one with the lesser speed, and because of that you have a viscous force, and you know that viscous force is given by minus eta A dV by dx. Minus sign indicates the opposite effect. So force per unit area dV by dx is your eta, which is also known as coefficient of viscosity, dimensionally ml minus 1 T minus 1. Now if you look at this, I have rearranged it. This is called, so these basically, this is your tangential stress that is developed between the layers, and this is dV by dx, this is called strain rate. So viscosity is like a liquid friction that does not allow the liquid to flow smoothly or freely. So it is like a liquid friction. So this is the coefficient of viscosity we have, and viscous force, that is opposite nature. So it depends on this area of contact, it depends on the velocity gradient, it depends on the nature of the material and all. And if you discuss viscosity, you have viscosity primarily a property of liquids. So viscosity primarily a property of liquids, and this viscosity is actually missing in gases. Reason being, gases molecules, they don't have interaction, whereas in liquids molecules they have interactive forces, cohesive forces. That is how. Now if you understand viscosity with temperature, so with increase in temperature, how the viscosity plays out. So with the increase in temperature, particularly in case of liquids generally, so cohesive forces get weakened, viscous force definitely gets weakened, molecules, they may get apart, so viscosity decreases. Whereas in case of gases, with the increase in temperature, because actually in gases interactive forces are missing, but with the increase in temperature the collision frequency increases and the probability of coming close or probability of developing some sort of interactive forces is there, so that increases. So viscosity increases in case of gases. So this is one. Viscosity is a measure of liquid's resistance to flow. Yes, this is true. This is what we have just discussed. In general, viscosity of liquid increases with increase in temperature. Look at this, viscosity in case of liquids, with the increase in temperature it is decreases. So statement 2 is definitely a wrong statement. So statement 1 is correct, but statement 2 is incorrect. So B option. SOS, take my name as Ved. Hi Ved, welcome. So we have Ved, we have Savita, we have Tiyasha, we have Divyaraj, we have that fast fire, that is Aditya. So all these students are there. Good, keep it up. I hope you people are gaining good. Savita is there. Now the ratio of shear stress to strain rate. Oh, this is what we have just covered. This is tensile stress is shear stress also, and that is coefficient of viscosity. So this is coefficient of viscosity. The clear option is D option. Now we have the concept of terminal speed. What is this terminal speed? So let's suppose you have a spherical body. Got it? Now you allow this body to be there in viscous medium. So initially this ball is dropped. So if body is dropped in viscous medium, got it? So its speed keeps on increasing because its weight is pulling it down, and the layers of the liquid also comes into play. So we have a viscous drag. This viscous drag as per Stokes' law is 6 pi eta r v, because this is a medium, so upthrust would be there. So these two forces would come into play, and finally a condition may come when this body will be in equilibrium. So after attaining equilibrium, equilibrium means net force is 0. So it means downward force, weight is being balanced by your upward force, that is upthrust plus that is viscous. So this is mg, and this is volume of the body, spherical body, 4 by 3 pi r cube density of liquid into g plus 6 pi eta r v, and this mass can also be written as, this is for the body, 4 by 3 pi r cube density of body into g. So this is how we have, and when body attains equilibrium, body continues to move with the constant speed so acquired, that is called its terminal speed. Acceleration of the body will not be there, so terminal speed comes out to be 2 by 9 r square, density of body minus density of liquid into g per unit eta. So this is very, very important formula. This is very, very important numerical. So as you drop a body, if you draw its graph, so when you drop a body, its speed keeps on increasing first and finally attains a terminal speed. So this is terminal speed. You got it or not? But if you throw a body, so initially throw means body has some speed, it attains the final terminal speed. So these are the two graphs also, and this is the expression for the terminal speed, very important expression. Got it? Surface tension. Let me just attempt one question based on this. So let's attempt one numerical. So numerical, let's suppose you have a big drop of size r, it's falling with its terminal speed maybe 2 centimeter per second. This drop splits into 8 droplets. So what is the terminal speed for this droplet is, keeping all the parameters same. So this is a liquid drop, terminal speed. So keeping all the parameters constant, we can say using the above expression, terminal speed is directly proportional to size. This is a bigger drop, 4 by 3 pi r cube. It splits into 8 small droplets. So capital R is 2 times r. So terminal speed of bigger drop, which is r square, terminal speed of smaller drop, which is small r squares. Take the ratio, this V, bigger drop is 2 centimeter, for the smaller drop we have to find out, and this is r, r is 4r square, so this is 4r square by r square, and when you solve it 2 by 4, so that gives me 0.5 centimeter per second as the terminal speed. So this is important area. Any doubt from this part? Then surface tension. So surface tension may be written as T or maybe sometimes S. So this is basically a property of liquids, and that is exhibited by the free surface. So molecules which are deep inside the liquid, they experience no net resultant force, but the molecules at the surface, so they experience some resultant force, and that is along the tangent. So this tangential force experienced per unit length of the free surface is called surface tension. So MLT minus 2 by L. So that gives me the dimensional formula. Newton per meter is the dimension. You got it or not? So this is the concept for the surface tension. So numerically, surface tension is same as that of surface energy. And this is numerically. Whereas if I need to define, so this surface energy is work done basically in increasing the surface area per unit increase in surface area, and numerically I can put surface energy as tension also. So that will help me to solve numericals based on this formula also. You got it? And this surface tension is a phenomena which is responsible for excess pressure inside a liquid drop. So we have a liquid drop that maintains its spherical shape. So this is pressure inside, we have pressure outside. So this excess pressure, pressure inside minus pressure outside is 2T by R, where R is the size of the radius. So if you have a liquid drop, so this is the first case, but if you have a soap bubble which has two surface areas, because inside is air, outside is air, so that excess pressure is given by 4T by R, and for air bubble is defined in liquid, so we have only one surface, free surface, so that is 2T by R only. So these are the formulas which you need to remember from this part also. Now, based on that, work done in blowing a soap bubble of radius with the surface tension. Now, work done is surface tension into increase in surface area. So, surface tension is 0.03 Newton per meter. Increase in surface area. So, initially you have surface area as 4 pi r square, and when it is blown off, blown off means final surface area 0. So this is 0 minus 4 pi r square, and this is 0.03 into 4 into 3.14 into r, 100 millimeter. So we know 1 millimeter is 10 to the power minus 3, so that makes it 10 to the power minus 1, square gives you this one, and when you solve it you will get the energy, definitely negative sign, so energy is given to that to blow off. So when you multiply all the three variables, so that will give you the answer for this. Got it? Now, next, based on this, a circular frame of wire having radius r is floating on the surface of a liquid of surface tension. This is sigma, the additional force other than its weight. So we know we have a frame, so frame of wire, so that is in contact with water from both the surfaces. So surface tension is basically force per unit length. So length is 2 pi r, because you have to pull it, from the surface of water. So free surface is 2 pi r into t, but you have two surfaces in contact, so that makes it this 4 pi r. Tension is sigma. So option C is the correct option. Now match the column. This is again one more variety we have. Match the entries in column 1 with column 2. P plus rho gh plus half v square. So this is your Bernoulli's theorem. So A goes with R. Okay, A goes with R. A1 V1 equal to A2 V2. This is your equation of continuity. So B goes with S. Then V is equal to root 2 GH. This is basically the velocity of a flux. So if you have a container full of liquid and if you make a small orifice, so the speed with which body or the liquid oozes out of this body, that is called velocity of a flux, and the height above this orifice is h. So velocity of a flux, we can calculate it as root 2 GH. So this is velocity of a flux. So it goes with this. F1 by A1 is equal to F2 by A2. This is your Pascal law. So it goes with P. So A goes with R, B goes with S, C goes with Q, D goes with P. So this is the third option, and this is again one of the important formats we have. Capillary rise. So this is the last topic we have. We know whenever you immerse any capillary in a liquid, so let's suppose if this liquid is water. So water will definitely rise, and this is the height. So the height or the rise or fall is given by h is equal to 2t cos theta by r rho g we have, where t is the surface tension, r is the radius of this capillary tube, rho is the density of the liquid, and g is the acceleration due to gravity. T is surface tension, theta is angle of contact. So look at this, what do you mean by angle of contact? So let me make you understand. So this is the common interface. You drop a tangent, what this tangent is making with the walls of the container within the liquid, this is called angle of contact. And if this angle of contact is acute, as in case of water, then definitely cos theta for the acute part will be positive and height would be there positive, so it means liquid level will rise. But if you observe this one, in case of mercury, so in mercury the level will fall, and if you look at this angle of contact is obtuse, and you know for this obtuse cos theta will be negative and height would be negative, so that means there is a fall of liquid. So this rise or fall of liquid is called capillarity, and we have good number of applications based on that. So capillary rise is purely again one of the phenomena exhibited due to the property of surface tension of liquids. So this is the last question. An aeroplane of mass 3 into 10 to the power 4 kg and a total area of this much is in a level flight at some altitude. The difference in pressure between the upper and the lower surfaces. This is purely based on the application of your Bernoulli's theorem. So we have pressure at the lower surface, we have pressure at the upper surface, and this pressure difference is because of these airflows which are there. So you have good number of streams. So if you have more streams, so kinetic energy would be more. So here if kinetic energy is more, pressure energy would be less, and on this side kinetic energy would be less, so pressure would be more, and this pressure difference multiplied by the area of the wings will give you the upthrust for the lift of the aeroplane, and that should be able to lift the weight of the aeroplane. So the difference in the pressure, so we have to find out this difference in the pressure. Mass is given to us 4 kg, g is 10, area is what, 120 meters square. So this goes, and you will have the answer. You got it? 4 kg meter square, and this will give us total area. Now there is one point to be noted. If this area is given to you for one wing, then you need to multiply it with a factor of 2 because plane has 2 wings. So this is the calculation part for this one, and that will help you to solve this. So this is mg, pressure difference, and meter square. I think you need to check the answer from this. So is it going with any one? 10 to the power 4. Yes, this is the one. This is, so now we have the option 2.5 into 10 to the power 3 Pascal. So this is all from our side. Myself, Puneet Kathuria, your physics faculty at Aakash, and I must congratulate you for attending this session, because you people have gained a lot about these two chapters, and I can assure you with this understanding, you can score really well in these two chapters, and I wish you good luck for your NEET 2025. Thank you very much. Thank you, bacho.